Welcome to the Dream Architect channel. Today, we will embark on a silent journey to the very edge of our home, to where the sun's breath dissolves into the eternal night of interstellar space. This is a journey to a border not marked on any map, to a frontier where the laws of our world give way to the laws of the galaxy. We will listen to the silence that stretches for billions of kilometers and peer into the darkness that holds the secrets of the birth and death of stars. This is not the anxiety of the void, but a hymn to infinity, a quiet poem about our tiny yet shining island in the universal ocean. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul at a time. And now, just breathe. Let your eyes grow heavy and your mind soften. Let us begin. Let's imagine that our entire solar system is not just a cold scattering of planets in a bottomless void, but something far more alive and fragile, a shining bubble blown by the very breath of the sun into the depths of space. This bubble, called the heliosphere, is the true, though invisible, boundary of our home, a protective cocoon woven from pure light and swift wind. The solar wind is not a gust of air as we know it, but a continuous supersonic stream of charged particles flying from the sun's incandescent corona at speeds of hundreds of kilometers per second. It washes over Earth, flows around Jupiter, touches the rings of Saturn, and rushes onward, creating this invisible sphere of influence, our only shield against the harsh and alien galactic environment. And this bubble of light is our only home, a fragile ship sailing in the infinite ocean of the galaxy, the thinnest membrane of warmth in the icy darkness of eternity. But this shining membrane is not a perfect sphere, as we might easily imagine. It is more like a deformed drop of water, distorted by an invisible headwind, the wind of the galaxy itself. Our solar system is not stationary. It hurtles through interstellar space at about 230 kilometers per second, and this cosmic motion compresses the heliosphere on one side, at our nose, and stretches it into a long, ghostly tail on the other. This tail, the heliotail, extends for unimaginable distances, perhaps hundreds of times farther than the distance from the Sun to Pluto. It is like the rarefied train of a royal gown, trailing behind us in our eternal dance around the galactic center. And this train of solar plasma slowly, atom by atom, dissolves into the void. The edge of this bubble is not a sharp line drawn on a map, but an entire region, misty and full of strange physical phenomena, known as the boundary of the heliosphere. It consists of several layers, each with its own unique physics, its own laws. The first frontier on this path is the termination shock, the place where the supersonic solar wind first encounters significant resistance from the interstellar medium and abruptly, almost catastrophically, slows down. It is similar to how a fast mountain river, flowing into a calm and dense ocean, loses its speed and forms a churning, chaotic estuary. Here, the order we are accustomed to ends, and a realm of uncertainty begins, the first quiet note in the symphony of farewell to home. This very solar wind, which creates and sustains our heliosphere, is itself a flow that is losing its essence, the breath of a dying star. Every second, the sun loses about 1 million tons of its mass, converting it into pure energy and this ceaseless stream of particles. This wind is literally the sun itself, dissolving into space, drop by drop, atom by atom, in an eternal act of self-sacrifice that grants us warmth, life, and protection. It carries the sun's magnetic field with it, stretching it like an elastic, invisible web throughout the entire system. And when this wind reaches the boundaries, it becomes so rarefied and weak that it can no longer be considered a wind, but rather a quiet, fading echo, the last breath of a star dissolved in eternity. The magnetic field that the solar wind carries with it forms a gigantic, elegant spiral known as the Parker spiral. As the sun rotates on its axis approximately every 27 Earth days, it twists the magnetic field lines emanating from it, like streams of water from a rotating garden sprinkler. At Earth's orbit, this field is still relatively straight, but the farther from the sun, the more it twists. At the edge of the solar system, near the heliopause, these field lines become almost perpendicular to the direction of the wind, creating a complex, tangled magnetic wall. This invisible wall is a crucial part of our defense, a complex labyrinth for galactic rays that try to penetrate our home, forcing them to wander and lose energy. Within this enormous spiral lies an even more subtle and amazing structure, the heliospheric current sheet. Imagine a giant, wavy sheet extending from the sun to the very boundaries of the system, which divides the magnetic field into two halves with opposite polarity, north and south. This sheet is not flat, but curved, like a ballerina's tutu, due to the tilt of the sun's magnetic equator relative to the plane of the planet's orbits. The Earth, as it orbits the sun, periodically passes through this sheet, crossing the boundary of magnetic polarities. This is a quiet, imperceptible process for us, but it is a fundamental element of space weather, conducting the flow of particles throughout the solar system, like an invisible conductor leading his orchestra. Our long journey through the galaxy does not pass through an absolute vacuum, but through a very rarefied cloud of warm gas and dust known as the local interstellar cloud. It is its barely noticeable pressure and faint but constant wind that deform our heliosphere, giving it an asymmetrical teardrop shape. We have been inside this cloud for tens of thousands of years and will remain in it for as long again before emerging into an even more rarefied medium. It contains atoms and dust left over from stars that exploded millions of years ago. Our heliosphere, like an ancient ship, cuts through the quiet waves of this ancient cloud, and their silent collision gives birth to the boundary toward which we mentally strive. Beyond the termination shock, in this cosmic estuary, there exists a vast zone where the solar wind, having already become subsonic, hot and turbulent, begins to mix with particles of the interstellar medium. This region is called the Helios Heath. It is a kind of gigantic turbulence zone, a huge space billions of kilometers thick, where predictable physical chaos reigns. Here, magnetic fields twist and reconnect, and plasma flows move in unpredictable directions. It is like the boiling foam that forms where the powerful waves of the ocean's surf meet a stationary rocky shore. This is the last, turbulent river one must cross to leave the home harbor of our world. The thickness of this turbulent zone, the Helios Heath, is still a subject of scientific debate and surprising discoveries. When the Voyager 1 probe crossed it, it sent data to Earth that forced scientists to completely revise their models several times. It turned out that this region is far stranger, more complex, and more dynamic than anyone could have imagined. It is not static. It breathes and pulsates with the 11-year cycle of solar activity. In years when the sun is active and hurls powerful ejections into space, the heliosphere expands, pushing the interstellar medium further away. In years of calm, it contracts, allowing the boundary to approach closer to us, like the sea during low tide. The heliopause itself is that very conceptual surface of our bubble, its farthest final line. It is the place where the pressure of the weakened, hot, and chaotic solar wind is finally balanced by the pressure of the external interstellar wind. It is a point of perfect equilibrium, an invisible but absolutely real membrane separating two worlds. To cross it is to truly, physically leave the solar system. Beyond it, the solar wind as a directed flow no longer exists. It has completely dissolved into the galactic gas. There begins a completely different world, dominated by laws, fields, and particles born of other stars and other distant and alien processes. Beyond this invisible boundary begins a completely different magnetic field, the interstellar one. It does not belong to our sun. It is part of the overall global magnetic field of our entire Milky Way galaxy. When Voyager 1 crossed the heliopause, its instruments recorded a sharp, almost fourfold increase in this field and a radical change in its direction. It was as if a compass that had been pointing to the same pole the whole way suddenly turned and pointed in a completely different direction. This was the clearest and most indisputable sign that our tiny messenger had left its native home and entered the boundless calm waters of the galactic ocean. The termination shock, the very first frontier on the way to the edge, is not the smooth and stable sphere depicted in diagrams. It constantly fluctuates, moves, and changes its shape, like the surface of a giant soap bubble in the wind. Sometimes it moves closer to the sun, sometimes it retreats by billions of kilometers. These fluctuations are caused by giant coronal mass ejections from the sun, which send powerful shock waves through the entire system. Reaching the boundary months later, these waves push it, causing it to vibrate. And the sound of this cosmic drum is a quiet hum of plasma, which we will never hear with our ears, but which our distant steel messengers sensitively record. Inside the Helios Heath, in this zone of predictable chaos, there are regions where the solar wind almost completely stops, losing all directional motion and turning into stagnant hot plasma. These are the so-called dead zones, or stagnation zones. Here, particles move randomly, and the magnetic field is tangled into complex, unstable knots, like a tangled ball of yarn. Voyager 1 spent several months in such a zone, and scientists on Earth were completely bewildered, not understanding whether it had already crossed the boundary or was stuck in some strange antechamber of space. It was like the calm before the storm, the still waters before a waterfall leading to another universe. One of the most surprising discoveries made at the boundary is the existence of giant magnetic bubbles in the Helios Heath. These are enormous structures, each about 150 million kilometers in size, which is comparable to the distance from the Earth to the Sun. Within them, the Sun's magnetic field detaches from its usual Parker spiral and curls into a closed cocoon, like a puff of smoke. These bubbles create a kind of magnetic foam, a tangled labyrinth that particles, traveling both from within and from without, must navigate. Our heliosphere at its edge is not smooth and solid, but rather porous, like a sponge, composed of these magnetic traps, each one a small, isolated world with its own laws. There is a phenomenon poetically called the ribbon. It is a giant, glowing arc in the sky that cannot be seen with the eyes, but only with special instruments sensitive to neutral atoms. It was discovered by the IBEX satellite, and it came as a complete surprise to astrophysicists. This ribbon is 2 to 3 times brighter than the surrounding background, and no one fully understands its nature. One of the leading theories states that this is where our solar magnetic field interacts with the galactic one at a specific angle, causing particles to radiate. It is like a giant neon sign at the border of our system that reads, "You are now leaving the sun's sector," but what it truly means remains a profound mystery. Just beyond the heliopause, like a thin veil enveloping our bubble, there exists another mysterious structure called the hydrogen wall. This is a region of space where neutral hydrogen atoms from the interstellar medium moving toward our system collide with the hot, charged particles of the outgoing solar wind. As a result of this interaction, they slow down and accumulate, creating a kind of dense fog or curtain around our solar system. We cannot see it directly in visible light, but we can see how ultraviolet light from distant stars is partially absorbed by this wall. It is another barrier, another veil, separating us from the rest of the galaxy. But even before this hydrogen wall, it seems there is another, hotter barrier. Data from the Voyagers and the IBEX satellite hint at the existence of a bow shock. This is a hypothetical region where the interstellar wind, which itself moves at supersonic speed relative to our heliosphere, must abruptly slow down and heat up. If our heliosphere is a ship, then the hydrogen wall is the fog around it, and the bow shock is the wake that the ship's bow creates as it cuts through the water. The existence of this wake depends on the speed of our movement and the density of the medium, and its detection would be another chapter in the story of our interaction with the galaxy, another echo of our motion. The particles that make up the interstellar medium are unlike what we know in our solar wind. They carry a completely different history. They contain the chemical composition of other star systems, perhaps remnants of supernovae that exploded millions of years ago, or matter from ancient molecular clouds where stars are just beginning to form. When we are finally able to fully study their composition with future missions, we will literally touch matter that has never been part of our world. It will be like an archaeologist finding an artifact from a completely unknown alien civilization. Every atom there is a silent message from the distant past and from distant alien worlds. The heliosphere protects us from most galactic cosmic rays, high-energy particles, mostly protons and helium nuclei, flying through space at nearly the speed of light. These invisible bullets can damage the DNA of living organisms and disable the electronics of spacecraft. Our heliosphere, thanks to its tangled magnetic field, deflects about 75% of these dangerous particles, forcing them to wander through its labyrinths. But at the boundary and beyond, this protection does not exist. The radiation level there is such that a person's prolonged presence in this environment would be fatal. This is one of the main dangers for future interstellar travel, an invisible and constant shower of cosmic shrapnel. When Voyager 1 crossed the heliopause, its detectors registered a sharp, almost instantaneous jump in the intensity of these galactic rays, as if it had stepped out from under a protective umbrella into a downpour. This was the final confirmation that it had left the protective cocoon. But the strangest thing is that just before crossing the boundary, the intensity of these rays briefly dropped to abnormally low levels. This suggests that the heliopause itself acts as a kind of final barrier, creating a thin wall before releasing the traveler into open space. It is like a final cautionary whisper from our home, a sudden calm before the real storm. However, the termination shock boundary itself is not only a shield, but also a cradle. It is here, in the zone of turbulence where the solar wind slows down, that a special type of particle known as anomalous cosmic rays is born. These are neutral atoms from interstellar space that lose an electron and are then repeatedly accelerated, bouncing off the shock wave like ping-pong balls between two paddles. Having gained enormous energy, they scatter throughout the heliosphere, including toward Earth. By studying them, we study particles born at the very edge of our world, children of chaos born at the boundary of two winds. They are messengers from a distant frontier, born right on our doorstep. There is compelling evidence that our heliosphere has not always been as it is now. Millions of years ago, the solar system may have passed through much denser interstellar clouds. During such periods, the heliosphere could have shrunk so much that its boundary would have been inside the orbit of Saturn, and perhaps even Jupiter. Earth would have been almost defenseless against galactic rays. It is possible that such events directly influenced the evolution of life on our planet, causing bursts of mutations or even contributing to mass extinctions. Our quiet and calm haven is not eternal, and its walls have not always been equally strong. Our home remembers times when the galactic ocean came almost to its very threshold. We still do not know the exact shape of the heliotail, which trails behind our system in its galactic flight. It was previously thought to resemble a long, straight sleeve, like a windsock, and extend for thousands of astronomical units. But recent data from the Cassini probe and the IBEX satellite show that it may be divided into 2 or even 4 separate lobes, similar to a cloverleaf. Or it could be curved, like a croissant, under the influence of an external magnetic field. We are trying to map a structure hundreds of billions of kilometers in size based on indirect data and readings from 2 tiny probes. It is like trying to draw a map of the ocean with only 2 corks with sensors floating on its surface. The pressure of the interstellar wind that compresses our heliosphere is not constant in time and space. It changes depending on which part of the local interstellar cloud we are currently flying through. This means that our entire solar system is constantly breathing, expanding and contracting on scales that are difficult for the human mind to imagine. This cosmic inhale and exhale takes thousands of years, and we are now living in one of the moments of this eternal cycle without even being aware of it. Our world pulsates to a rhythm that we cannot feel, but which defines the very shape and size of our cosmic home. Beyond the heliopause, in the pure interstellar medium, Voyager 1 discovered something completely unexpected: sounds. Of course, this is not sound in our understanding, as an almost perfect vacuum reigns there. But its instruments recorded oscillations in the density of plasma, the rarefied interstellar gas. These oscillations, translated into the audio range, are heard as a quiet, monotonous hum, sometimes interrupted by sudden bursts resembling crackles or clicks. This is the voice of the void, the song of interstellar space, heard for the first time by a messenger from Earth. And in this strange, monotonous song, one can hear the very breath of eternity, the silent hymn of the cosmos. These sudden bursts in the song of interstellar space, as it turned out, are caused by shock waves from our own sun. When a powerful flare or coronal mass ejection occurs on the sun, it sends a wave that rushes through the entire heliosphere. A year or even more later, this wave reaches the heliopause, crosses it, and crashes into the interstellar plasma, causing it to ring like a taut string. It turns out that even after leaving home, Voyager still hears its distant echo, coming from behind. Our sun makes its presence known even where its dominion has formally ended, sending a message to its distant wanderer. These plasma oscillations, which the Voyagers detect, are known as Langmuir waves. They arise when a stream of electrons, for example, from a solar shock wave, passes through the plasma, causing ripples in it, much like a motorboat leaves a wake behind it on the water. This is not sound, which can propagate in a vacuum, but collective oscillations of the medium's particles themselves. By registering the frequency and amplitude of these waves, scientists can determine the density of the interstellar gas with incredible precision, a parameter that is impossible to measure directly at such a distance. It turns out we are hearing not sound, but the very density of the void, its finest structure, voiced by the echo of our sun. The speed of sound in the interstellar medium is completely different from what we are used to on Earth. Due to the extremely low density and high temperature of the plasma, it is about 100 kilometers per second, which is hundreds of times faster than the speed of sound in air. The solar wind, up to the termination shock boundary, moves at a speed of 300 to 400 km/s, meaning it is supersonic by local standards. After crossing this boundary, it decelerates sharply and becomes subsonic. This boundary is a real sound barrier, not for an airplane in the atmosphere, but for an entire star system flying through the rarefied galactic gas. The direction in which our solar system is moving does not coincide with the direction of the surrounding interstellar magnetic field. They are inclined to each other at an angle of about 60 degrees. This creates a complex asymmetrical interaction structure. The heliosphere is not simply compressed at the front. It also slides along the magnetic field lines like a bead on a string, but with the string pressing on the bead from the side. This asymmetry and lateral pressure, scientists believe, are the key to understanding many strange phenomena at the boundary, such as the unusual shape and brightness of the mysterious ibex ribbon, which may be a trace of this sideways sliding. This phenomenon, where an external magnetic field flows around an obstacle, is called magnetic draping. The interstellar magnetic field lines, unable to penetrate the heliosphere, bend and flow around it, like fabric draped over a ball. They become denser in front of the heliopause, creating a region of strengthened magnetic field, another invisible barrier on the way to our home. It is in this draping zone that many of the mysterious processes we are only beginning to understand take place. Our bubble does not simply float in the magnetic field, it actively changes its structure around itself, causing the galactic lines of force to respectfully part before it. The interstellar medium is extremely heterogeneous. Right now, we are in a relatively empty bubble of hot gas called the local bubble. It is about 300 light-years in size and was likely blown out by the explosions of several supernovae that occurred 10 to 20 million years ago. Our local interstellar cloud is just a small, slightly denser and cooler condensation inside this giant bubble. But in a few tens of thousands of years, we will leave this cloud and enter an even more rarefied medium. And then our heliosphere will change again, perhaps expanding significantly, and its boundaries will recede even further into space. The supernova explosions that created our local bubble played a key role in our cosmic history. These titanic events not only cleared the space around us, but also enriched it with heavy elements: carbon, oxygen, iron, everything that planets and we ourselves are made of. The interstellar medium in which we are now immersed holds the memory of these ancient cataclysms. The dust and gas washing over our heliosphere are the ashes of long-dead giant stars. We are traveling through a ghostly echo of creation, through material that will one day become the foundation for new worlds. And we ourselves are made of this stardust. There is also an alternative hypothesis that the heliosphere may not have a long, comet-like tail at all. Instead, it might be nearly spherical, like a bubble. Some computer models show that interaction with a strong interstellar magnetic field could shear off the tail, causing the solar wind plasma to dissipate and mix with the surrounding medium quickly. In this case, our solar system resembles not a comet, but a jellyfish swimming in the ocean, with short, tangled tentacles behind it. Only future missions that can look behind our system will show which model is correct. Particles that are born at the boundary of the heliosphere can reach Earth itself. These are the so-called energetic neutral atoms, ENAs. They form when a fast solar wind ion collides with a slow neutral atom from the interstellar medium and exchanges an electron with it. As a result, the ion becomes a neutral atom and continues in a straight line, unaffected by magnetic fields. Some of them fly back towards the sun and can be detected by satellites in Earth's orbit. By studying them, we see the boundary without leaving home, as if looking into a vast cosmic mirror reflecting a distant and invisible frontier. Besides ENAs, there is another phenomenon called pickup ions. These are the same neutral atoms from the interstellar medium that penetrate the heliosphere, but then, under the influence of solar ultraviolet radiation or collisions, lose their electron and become ions. At that moment, they are instantly picked up by the solar wind's magnetic field and carried away from the sun. These newborn ions carry information about the velocity and composition of the interstellar gas. They are like spies who have infiltrated our home and are immediately sent back with a report, which we intercept at the boundary by studying their energy and direction. The very fact that we can study this boundary is a true technological marvel. The distance to it is over 120 astronomical units, which is 120 times farther than from the Earth to the Sun. That's about 18 billion kilometers. Light from there takes almost a day to reach us. The signal from Voyager, traveling at a speed of 17 kilometers per second, takes over 22 hours to reach Earth. And this signal has a power 20 billion times weaker than that of a wristwatch battery. We are listening to a silent whisper from the edge of the world, capturing it with giant antenna ears, and this whisper tells us about our place in the universe. The Voyager 1 and Voyager 2 probes are our only direct witnesses to these distant places, our eyes and ears at the edge of the world. Launched in 1977, they were originally intended to study Jupiter and Saturn. Their interstellar mission is pure luck, multiplied by the genius of the engineers who calculated a trajectory to use the planet's gravity for acceleration. They have been operating for over 45 years on plutonium generators that are slowly losing power. Each year, engineers have to turn off more scientific instruments to save energy for the most essential ones. It is a desperate race against time until the probes fall silent forever, carrying their secrets into eternity. Voyager 2 entered interstellar space at a different place and time than Voyager 1, and its data turned out to be somewhat different. It recorded a smoother and clearer transition, without the long periods of stagnation in dead zones that its twin brother observed. This suggests that the boundary of the heliosphere is not just non-uniform in space, but also variable over time. It is alive, breathing, and its mood depends on where and when one crosses it. No two paths from home are the same. Each traveler sees their own unique threshold, and each tells their own story about it. On board each Voyager is a gold-plated copper record, a message in a bottle, cast into the cosmic ocean for hypothetical extraterrestrial civilizations. It contains recorded sounds and images of Earth, the sound of wind and rain, a baby's cry, greetings in 55 languages, and the music of Bach, Mozart, and Chuck Berry. These probes are not just scientific instruments, they are our silent ambassadors, carrying a message about humanity into eternity. Even when they fall silent, they will continue their endless journey through the galaxy, carrying with them the memory of a small blue planet and its curious inhabitants. They are the most distant handprints we have left on the walls of space. But even these eternal messengers are not immune to slow decay. Their golden records, though protected by an aluminum case, will eventually be subject to erosion. The tiniest particles of interstellar dust, flying at enormous speeds, will bombard them like a sandblaster. Over millions of years, this cosmic erosion will slowly erase the grooves on the record, and the music of Bach will fall silent, and the images of Earth will disappear. Even our most durable creation will eventually dissolve into the void, leaving only gold dust behind. Eternity does not like long-lasting evidence. It prefers silence and oblivion. The power of Voyager's transmitter is only 23 watts, about the same as the light bulb in your refrigerator. To receive this infinitely faint signal, giant antennas of the Deep Space Network, located in California, Spain, and Australia, are used on Earth. The diameter of each dish reaches 70 meters. It is like a desperate attempt to hear the whisper of a person standing on the moon. Every bit of information received from the edge of the solar system is the result of incredible effort and a technological miracle, a quiet triumph of our insatiable desire to know what lies there, beyond the horizon. The Voyager's plutonium generators, or RTGs, will produce enough power to operate at least one scientific instrument until approximately 2025 to 2030. After that, they will fall silent forever, becoming silent ghosts flying in the darkness. But their trajectories have been calculated. In 40,000 years, Voyager 1 will fly relatively close to the star Gliese 445 in the constellation Camelopardalis, and Voyager 2, in 296,000 years, will approach the brightest star in the night sky, Sirius. Their true interstellar journey is just beginning, and we are merely seeing them off with our gaze, standing on the threshold. Even after the probes fall silent, their study may not cease. Astronomers will try to track their faint thermal radiation with the most powerful future telescopes to verify our calculations of their trajectories. And in the very distant, almost fantastical future, perhaps new, faster ships will be sent to them, to catch up with them and turn them into museum exhibits, priceless witnesses to the dawn of humanity's space age. They are our first steps into eternity, and we will most likely want to preserve the memory of these timid, yet so important steps. The information we receive from the Voyagers arrives with a huge delay. When scientists on Earth send a command to a probe, for example, to deploy a platform or turn on an instrument, they have to wait almost 2 days for a response. It is work in a mode of dialogue with the past. Every decision must be extremely deliberate and well thought out, because correcting a mistake will be practically impossible. This is the slowest and most thoughtful research in the history of science, a quiet and respectful conversation across the abyss of time and space, where every word carries the weight of eternity. Besides the Voyagers, other spacecraft are also approaching the edge of the solar system: Pioneer 10, Pioneer 11, and New Horizons. The Pioneers have long since fallen silent, but they continue their silent journey into interstellar space, carrying plaques with an image of a human. New Horizons, which flew past Pluto and the Kuiper Belt object Arrokoth, is still operational and transmitting data. It will reach the heliopause in approximately the 2040s and will give us a third invaluable point on the map of this mysterious region if its power does not run out sooner. Each of these spacecraft is a separate story, a separate view of the edge of our world. The temperature in the interstellar medium is paradoxical and completely counterintuitive. If we talk about the kinetic temperature of individual atoms, it is thousands or even tens of thousands of degrees. They move at enormous speeds, but the density of matter is so negligible that any object placed there, for example, a spacecraft, would instantly freeze to a temperature close to absolute zero, radiating its own heat into the void. It is a hot void in which one can freeze to death. The sensation of heat and temperature are completely different things at the edge of our world, where the concepts familiar to us lose all meaning. There is a theory that the shape of the heliosphere may be related to the direction of the galactic magnetic field. If the field were oriented differently, our heliosphere might not be elongated, but, on the contrary, flattened, or have an even more bizarre, exotic shape. We live inside a structure whose shape has been dictated not only by our sun, but by the entire galaxy. Our home is the result of a quiet dialogue between two forces, a local one, emanating from within, and a universal one, pressing from without. And in this dialogue, the fragile harmony of our existence is born. The dust that fills interstellar space is very different from the dust in our solar system. It is looser and fluffier, similar in structure to snowflakes or tiny clumps of soot. It consists of tiny silicate and carbon cores covered by a thick mantle of water ice and frozen organic molecules. When these dust particles enter the heliosphere, they carry with them information about the chemical composition of the galaxy. Some of them reach Earth in the form of micrometeorites, and by studying them, we can touch matter that is older than our sun. These are true letters from the past, delivered by the galactic wind. The voyagers discovered that the magnetic field in the interstellar medium is much more orderly and stable than the chaotic field inside the Helios heath. This field, like invisible threads, permeates all of space, guiding the movement of charged particles and forming galactic-scale structures such as filaments and gas clouds. We are floating in a calm magnetic ocean, whose existence we did not even suspect until recently, protected from it by our own, more turbulent and chaotic field. We live in a small storm in the middle of a great calm. When the solar wind collides with the interstellar medium, a continuous process of charge exchange occurs. Fast protons from the solar wind capture electrons from slow hydrogen atoms from the interstellar medium. As a result, fast neutral hydrogen atoms are formed, which no longer feel the influence of magnetic fields and travel in straight lines. These energetic neutral atoms, ENAs, fly off in all directions, and it is these that the IBEX satellite studies to map the boundary. We see the boundary in the light of these newborn free particles that fly to us directly from the battle site of the two winds, telling us about its shape and structure. The very existence of the heliosphere is a huge stroke of luck for life on Earth. If the sun were a less active star with a weaker wind, or if we were traveling through a denser interstellar cloud, the heliosphere could be much smaller. In that case, Earth would be exposed to much more intense radiation from galactic rays. Perhaps complex life on our planet owes its existence not only to the right distance from the sun, but also to this giant invisible shield that extends for billions of kilometers, absorbing the impacts of the cosmos. Beyond the heliopause, time flows just as it does for us, but the perception of it completely changes. For Voyager, decades have passed since its launch, but on a galactic scale, this is just a fleeting moment. It flies through a space where fundamentally nothing has changed for millions of years. This is a journey into a world of geological, cosmic time, where human life is but a flash of light, an instantaneous firework in the eternal night. On the edge of our system, we encounter not only the infinity of space, but also the silence of eternity, which swallows all our scales. If we could look at our heliosphere from the outside in X-rays, it would probably glow with a faint, ghostly light. The interaction of solar wind ions with neutral atoms of interstellar gas should generate a weak but noticeable X-ray emission. Our solar system is not a dark object, but a dim beacon glowing in the galactic night. And this light is the light of a battle between two winds at the boundary of worlds, the quiet radiance of our home, visible only to the most sensitive eyes we might ever create. Our home glows, but we do not see it. Even our fastest spacecraft move negligibly slowly compared to the size of the galaxy. To reach the nearest star to us, Proxima Centauri, Voyager would need about 75,000 years. The boundary of the solar system is not a threshold for rapid interstellar travel, but only the first tiny step out the door of our own home. The ocean we must cross to reach other island stars is almost infinite, and our current ships are but fragile splinters in its slow, eternal waves. This realization is both humbling and inspiring. In the Helios heath, in this chaotic zone, magnetic fields can form so-called magnetic islands, regions of plasma completely cut off from the sun's main magnetic field. They are like drops of oil in water, living their own separate lives. Particles trapped in such an island can be confined there for a long time before breaking out again or dissipating. This is another element of the complex labyrinth that nature has built on our doorstep to separate the inner order from the outer chaos. The boundary is not a wall, but a series of rooms and corridors full of traps and puzzles. Besides the hydrogen wall, there is also a helium cone. Neutral helium atoms from the interstellar medium penetrate the solar system much more easily than hydrogen atoms because they are heavier and less susceptible to interaction at the boundary. Under the influence of the sun's gravity, they are focused into a cone on the side opposite the direction of the system's motion. By studying this helium cone with spacecraft like Ulysses, we can very accurately determine the speed and direction of our flight through the interstellar cloud. Helium serves as our precise cosmic weather vane, pointing to the wind that washes over our home. The concept of the boundary is fluid and depends on the definition. If we define the solar system by the influence of the solar wind, then its edge is the heliopause. But if we define it by the sun's gravitational influence, then it extends much farther, all the way to the Oort cloud. This means that even after leaving the heliosphere, the Voyagers will remain in the sun's gravitational well for tens of thousands of years. They have left the house, but are still in its vast, invisible yard, tied to it by the thinnest thread of gravity. The pressure of sunlight also makes its tiny but constant contribution to the dynamics at the edge of the system. Photons of light exert pressure on the tiniest dust particles, slowly pushing them out of the solar system. This effect is called radiation pressure. At the edge of the system, it is almost imperceptible against the backdrop of the powerful solar wind, but over millions of years, it helps to clear space, creating another, most subtle and ghostly kind of wind. A wind of pure light. Even light has weight and power in this quiet, slow drama at the edge of the world. When Voyager 2 crossed the heliopause, it discovered that the boundary was much hotter than expected. The plasma temperature there reached 30,000 to 50,000 degrees Celsius. This is not the kind of heat one could feel, due to the negligible density, but it speaks to the colossal energy released during the collision and deceleration of the solar wind. It is a true hotline at the edge of our world, an invisible fiery frontier where the kinetic energy of the flow is converted into pure heat, which is immediately dissipated into the void. The interstellar medium through which we are flying carries the seeds for future stars and planets. The dust and gas that now wash over our heliosphere will one day, in millions of years, gather into new giant molecular clouds to be compressed by gravity and give birth to new suns and new planets. Flying through them, we are flying through the past and future of the universe simultaneously. Our heliosphere is a temporary bubble in the eternal stream of cosmic creation, a drop of the present in the river of eternity. A future mission called the Interstellar Probe is already being developed by NASA engineers and scientists to specifically study the boundary and interstellar space. It is planned to travel 3 to 4 times faster than the Voyagers and could reach the heliopause in just 15 years. It will carry a new generation of instruments that can answer many of the questions posed by its legendary predecessors. This will be our conscious and deliberate step into the unknown. A step taken not by chance, but with a full understanding of its purpose. The Voyagers operate on onboard computers with a total memory of about 68 kilobytes. A modern smartphone is millions of times more powerful. But these simple, reliable, and multiply-redundant systems, developed in the 70s, have managed to withstand decades in deep space, survive intense radiation, and make some of the greatest discoveries in human history. Sometimes simplicity and resilience prove to be more important than raw computing power, especially on such a long and lonely journey where there is no room for error. There is a troubling asymmetry in the heliosphere that we cannot yet fully explain. The ibex ribbon is brighter on one side than the other, and the southern hemisphere of the heliosphere appears to be pushed inward more than the northern one. It is as if some external unknown force were pressing on our bubble, the direction of which we cannot precisely determine. The galaxy is full of mysteries, and some of them are literally knocking at our door, leaving barely perceptible dents on it that we are trying to decipher. The termination shock not only slows down the solar wind, but also heats it significantly. The plasma temperature beyond it jumps from a few thousand to 1,000,000 degrees. This hot but extremely rarefied gas fills the entire Helios heath, the vast space between the termination shock and the heliopause. The Voyagers flew through this invisible furnace for many years, and their heat shields were designed to withstand it, although it would have been impossible to feel this heat. It is a realm of invisible heat where one can freeze in a fire. If we could see in the radio range at very low frequencies, the boundary of the solar system would be glowing. Electrons, accelerated to high energies at the shock wave, emit radio waves as they move in a magnetic field. Astronomers are trying to capture this faint emission with ground-based and space radio telescopes to better understand the processes occurring there. Our home is surrounded not only by a wall of plasma, but also by a halo of radio noise, the quiet song of accelerated particles, an eternal hymn to its own boundary. One of the biggest mysteries today is why the heliosphere lets in so many neutral hydrogen atoms from the interstellar medium at all. Theoretically, the interaction at the boundary should have ionized them much more effectively, preventing them from penetrating the system. The fact that they do penetrate in large quantities suggests that our models of the boundary are still incomplete. Perhaps there are some pores or temporary windows in the heliopause through which interstellar gas seeps in, like water through a poorly constructed dam. The interstellar magnetic field we have entered is not absolutely static. It also fluctuates and changes under the influence of distant supernova explosions, stellar winds from massive stars, and other turbulent galactic phenomena. These fluctuations, like slow ocean waves, reach our heliosphere and cause it to vibrate and change shape. We live in a bubble that trembles in time with the life of the entire galaxy, feeling its distant breath, its slow and mighty pulse. Our home is not isolated. It listens keenly to the music of the universe. When Voyager 1 crossed the boundary, it discovered that the Sun's magnetic field and the galactic magnetic field do not reconnect or mix. They lie side by side, like two layers of immiscible liquids, separated by a distinct boundary. This means that at this point, our heliosphere was completely magnetically isolated from the rest of the galaxy. It was not just a bubble, but a perfectly sealed vessel floating in an alien medium, an impenetrable barrier separating ours from theirs. But the data from Voyager 2, which crossed the boundary in a different location, showed something completely different. At its point of crossing, the magnetic fields of the Sun and the galaxy seem to be connected to each other in a process called magnetic reconnection. This means that our heliosphere might be leaky in some places, allowing plasma and energy to seep in and out. The boundary is not uniform across its entire surface. It can be both an impenetrable wall and an open door at the same time, depending on where you are. Our home has both locks and windows. Far beyond the orbit of Neptune begins the Kuiper Belt, a giant ring populated by millions of icy bodies left over from the formation of the planets. But it too is not the edge of the solar system. It smoothly transitions into the so-called scattered disk, where objects have highly elongated and inclined orbits. This is a zone of gravitational chaos created by the influence of Neptune in the distant past. And only beyond it begins the true void, leading to the last, most majestic, and most ghostly frontier. This final frontier is the hypothetical Oort cloud. It is a giant spherical shell surrounding the solar system at a distance of several thousand to 100,000 astronomical units, which is almost a light year. It is believed to consist of trillions of icy comet nuclei, ejected from the inner solar system at the dawn of its existence. It is the largest and most desolate object in our system. The distance between neighboring bodies within it can be millions of kilometers. It is a sphere of solitude surrounding our world. The Oort cloud is so distant that its objects are barely held by the sun's gravity. The slightest external disturbance, a passing star or a powerful gravitational wave from the galactic center, can knock a comet from its stable orbit and send it either on an eternal journey through interstellar space or into a long fall toward the sun. It is from there that long-period comets come to us, ghostly visitors from the icy darkness, carrying the memory of the world's birth. They are the tears shed by our farthest frontier. We have never directly seen a single object in the Oort cloud. They are too small, dark, and unimaginably distant for our telescopes. Its existence is merely a beautiful and elegant theory based on studying the orbits of comets that visit us. But it is one of the most majestic and frightening theories in astronomy. It suggests that our home is surrounded by a gigantic, invisible graveyard of construction debris, a sphere of icy phantoms at the very edge of existence. It is a silent, frozen archive of our birth. The outer boundary of the Oort cloud is the true gravitational edge of the solar system, the so-called Hill sphere. Beyond it, the gravity of other stars and the galaxy as a whole becomes stronger than the pull of our sun. An object that crosses this invisible line will never return. It is the point of no return, a true farewell to home. The voyagers will need tens of thousands more years to reach this final boundary, leaving the last outpost of the sun's domain and becoming truly interstellar wanderers. Even in the icy silence of the Oort cloud, an invisible struggle continues. Galactic tidal forces, the difference in the gravitational pull of the galactic center on the near and far sides of the solar system, constantly batter and stretch this cloud. They slowly steal the sun's most distant comets, carrying them away on an eternal journey through the Milky Way. The galaxy is slowly dismantling our home brick by brick, starting with its most distant and weakly bound walls. It is a slow but inexorable process of cosmic decay. There is a very real possibility that other stars pass through the Oort cloud from time to time. Such events occur, on average, once every few 100,000 years. A star's passage causes gravitational chaos, sending a veritable shower of comets toward the inner planets. Such a comet rain could be the cause of mass extinctions on Earth. About 70,000 years ago, for example, a dim red dwarf known as Schultz's star passed through the cloud. The distant frontier is not so distant from our fate, and its disturbances can ripple all the way to us. The temperature in the Oort cloud is only a few degrees above absolute zero, around 4 to 5 kelvins. It is one of the coldest places in the entire known universe. Matter here is frozen in an eternal sleep, preserving an untouched memory of the chemical composition of the nebula from which the solar system was born 4.6 billion years ago. Every comet there is a perfect time capsule, an untouched sample of primordial matter, waiting for its moment to tell us the story of our origin. The Oort cloud is so vast that it takes light more than a year to cross it. If you imagine the solar system up to Pluto's orbit as the size of a coin, the Oort cloud would be a sphere the size of a large city, with this tiny coin lying at its center. And this entire gigantic sphere is almost completely empty, filled only with silence and cold. This realization of scale and emptiness is one of the most unsettling and simultaneously majestic discoveries of modern astronomy. Our home is surrounded by an ocean of emptiness that is also a part of it. There is a hypothesis about the existence of an undiscovered giant planet, or even a small companion star to the Sun, sometimes called Nemesis, in the far reaches of the solar system, possibly in the inner Oort cloud. The search for these objects is underway, but so far without success. If such an object exists, it could explain some strange anomalies in the orbits of the most distant Kuiper Belt objects. Our home may not be as lonely as we think, and its biggest secrets may be hiding in the deepest and coldest shadow at the very edge of its domain. Particles of interstellar dust that penetrate the solar system carry microscopic traces from collisions with galactic cosmic rays. By studying these tracks in a laboratory, like tree rings, we can learn about the history of the radiation environment in our part of the galaxy over the last millions of years. The dust that quietly settles on Earth is a priceless archive, a chronicle of distant galactic events such as supernova explosions or passages through regions of high radiation. The galaxy writes its history on the smallest of pages. The Voyagers discovered that the boundary of the heliosphere hums in the radio spectrum. Sometimes, after a powerful shockwave from the sun reaches the heliopause, bright but short radio bursts occur, lasting for several months. It is as if someone struck a giant bell, and its hum slowly fades into the silence. This bell is our entire solar system, and the hammer is its own heart, the sun. Our home rings, and we are learning to listen to this music of the spheres, the music of the boundaries. Some scientists believe that the heliosphere may be, in principle, an unstable structure. There are models in which, under certain conditions, for example, upon entering a very dense or highly magnetized interstellar cloud, the heliosphere could collapse, shrinking to almost the orbit of Earth, or, conversely, inflate to enormous sizes. We live in a fragile equilibrium that can be disrupted by external forces at any moment during our long journey through the galaxy. Our shield is not eternal, and its strength depends on which ocean we are crossing. In interstellar space, just beyond the heliopause, the Voyagers encountered true tsunamis of shockwaves generated by our sun. These waves, traveling for more than a year from the sun, merge with each other, forming one giant, powerful wave. This means that even after leaving the heliosphere, you are not free from the sun's influence. Its wrath catches up with you even in foreign domains, a reminder of the power of the home left behind. The sun does not let its wanderers go so easily. Its voice echoes after them for a long time. The Oort cloud may contain not only comets born along with the sun, but also captured objects from other star systems. When other stars passed by the sun in the distant past, its gravity could have stolen a few comets from their own Oort clouds. This means that at the very edge of our system, there may be true envoys from other worlds, unwilling captives of our gravitational field. Our home might be the keeper not only of its own history, but also of fragments of other, long-forgotten histories. We do not know for certain what will happen to the heliosphere in the distant future. In 5 billion years, the sun will exhaust its hydrogen fuel and become a red giant. It will swell, possibly engulfing the inner planets. Its solar wind will become much more powerful, but slower. The heliosphere will expand to incredible sizes, and then, when the sun sheds its outer layers and becomes a white dwarf, it will disappear forever. Our bubble will burst, and its remnants will be scattered by the galactic wind like a final breath. The boundary of the solar system is not a wall, but a process. It is a place of constant exchange of energy and matter between our world and outer space. Something penetrates inward, something is ejected outward. It is a living, breathing membrane through which our small world communicates with the vast galaxy. By studying it, we are not studying the end of our world, but the beginning of its connection with everything else. It is not a barrier, but a bridge, across which eternity comes into our home, and our home goes into eternity. Data from the Voyagers show that interstellar space is not perfectly smooth and uniform. It contains filaments and clumps of plasma with increased density. Our heliosphere, as it travels through them, experiences additional pressure, which causes it to fluctuate and compress. We are flying through a non-uniform fog, and each denser clump of it is like a small jolt to our bubble-like spacecraft. Our journey is not a smooth glide, but a constant struggle with the invisible terrain of space. There is the mystery of the outbound solar wind. Some data from Voyager 1 indicate that even beyond the heliopause, there is a small number of particles that still seem to be flowing from the sun. This may be because the boundary is not perfect, and some of the solar wind leaks through it in a process of magnetic reconnection, creating a thin, ghostly stream in interstellar space. This is the last, quietest echo of our wind, stubbornly flying into infinity. One of the most unsettling thoughts is that we may never get answers to all the questions about the boundary. The Voyagers will fall silent within the next decade. New missions, such as the interstellar probe, might not be launched due to their complexity and cost. The boundary is so distant and so difficult to study that many of its mysteries may remain unsolved forever. It will remain for us an eternal symbol of the limit of our knowledge and our insatiable desire to look beyond it. It is an eternal horizon that will always beckon to us. When we look at the night sky, we see the stars through the entire thickness of the heliosphere. It is completely transparent to light. But for low-energy charged particles, it is an almost impenetrable wall. This dualism, transparency for one thing and impenetrability for another, makes it even more mysterious and amazing. It is a phantom barrier that we cannot see, but which defines the fundamental conditions of our existence. It lets beauty pass through, but holds back danger. The latest measurements from Voyager 2 have shown that the heliosphere may be more squashed and compact than previously thought. The distance to the boundary in the direction of the system's nose turned out to be less than many models predicted. This could mean that the pressure of the external interstellar medium is stronger than we thought. Our bubble is under greater stress than we supposed. It resists the outside world more stoically and intensely. Our home is a fortress under constant siege. The very idea of a boundary is a human construct, our attempt to impose order on infinity. In nature, there are no clear lines. There are only smooth gradients, transition zones where one phenomenon slowly fades while another just as slowly gathers strength. By calling this place a boundary, we are trying to organize the universe, to superimpose a map we can understand onto it. But the universe is not obliged to follow our maps. Its true poetry lies in transitions and halftones, not in rigid definitions and lines. Studying the boundary of the heliosphere is, in a sense, studying ourselves. It is an attempt to understand where our home ends and the rest of the universe begins. It is the definition of our place in the cosmos. And the answer we receive is at once frightening in its scale and calming in its harmony. Our home is vast and complex, but it is just a tiny grain of sand on the infinite beach of the galaxy, connected to every other grain by invisible threads of wind, light, and gravity. Someday, millions of years from now, the silent remains of the Voyagers might be found by another civilization, unknown to us. And then that little golden record will tell them about us, about our music, our languages, and our desire to reach a hand across the void. The boundary of our solar system will become the beginning of the story of humanity for someone else. And in this, there is a quiet cosmic poetry, a hope sent into eternity on the wings of the slowest ship. This boundary is not static. It breathes with the sun. Every 11 years, with the peak and decline of solar activity, the entire structure of the heliosphere expands and contracts by billions of kilometers. We live inside a pulsating heart whose rhythm is set by our star, and this pulsation echoes quietly at the very edge of our world, like the slow beats of a cosmic pulse. Our world is alive and dynamic to its very limits. It breathes in time with its star. Every atom that crosses this boundary carries a unique story. An atom arriving from interstellar space might be the remnant of a star that exploded billions of years ago in another part of the galaxy. An atom leaving our system as part of the solar wind might have been born in the thermonuclear heart of the sun just a few weeks ago. The boundary is a meeting place of times, a crossroads of atomic destinies, where the galaxy's past meets the present of our sun. It is a place where eternity and an instant touch each other. Our journey through the galaxy is not a straight line. Together with the sun, we orbit the galactic center, completing one revolution in about 230 million years. Along this path, we cross the spiral arms of the Milky Way, where the density of gas and dust is higher, and where new stars are actively being born. As we pass through such an arm, our heliosphere contracts, and as we exit into the inter-arm space, it expands. Our home is an eternal wanderer, traveling the streets of a stellar city, and the landscape outside its window is constantly changing on a scale of millions of years. The anxiety we might feel when thinking about this boundless frontier is not fear. It is awe. It is the same feeling a child has standing on the shore of the ocean and for the first time realizing its infinity. It is the understanding that the world is much larger, more complex, and more wondrous than we could have imagined. And this boundary is merely a threshold to even greater wonders, just the first page in a book that has no end. It is an invitation to humility and to endless discovery. Our journey to the edge of the solar system is coming to an end, but the silence of this place remains with us. It is not the anxiety of emptiness, but the peace of infinity. We have touched the invisible walls of our home and realized that they are not a barrier, but merely a membrane connecting us to the vast, breathing universe. And in this connection, in this awareness of being part of something greater, there is a deep sense of peace. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul at a time. And now, just breathe. Let your eyes grow heavy and let the quiet stellar winds lull your thoughts. Good night.